Greetings, curious humans. Welcome to another exciting episode of Cosmic Chronicles. Today, we embark on a thrilling journey to explore our neighboring planet, Venus. In this captivating YouTube video, we'll dive into the mysteries, myths, and scientific discoveries surrounding Venus, unraveling its secrets along the way. Venus, named after the Roman goddess of love and beauty, has a captivating allure that goes beyond its enchanting name. Despite sharing similarities in size and composition with Earth, this celestial body boasts an extreme and unforgiving environment. But what lies beneath the veil of Venus' dense atmosphere? Over the years, robotic missions and groundbreaking scientific research have begun to unveil the truth about this enigmatic planet. Discoveries of potential phosphine gas and intriguing atmospheric phenomena have sparked a renewed interest in the search for signs of life. As we gaze towards the future, the prospect of human exploration of Venus becomes a tantalizing possibility. Scientists and engineers have proposed innovative concepts, such as floating cities in the Venusian atmosphere, as potential habitats for human presence. So join us on this celestial adventure as we delve into the wonders of Venus. From its rich mythological connections to the latest scientific breakthroughs, we will traverse the realms of imagination and exploration. Get ready to expand your horizons and embark on a captivating exploration of the planet Venus. Venus, the second planet from the Sun, has a rocky surface and a dense atmosphere. It appears as a morning star or an evening star due to its proximity to the Sun. With its prominence in Earth's sky, Venus has been culturally significant and studied in astronomy. The planet has a thick carbon dioxide atmosphere and a global sulfuric acid cloud cover, resulting in an extreme greenhouse effect. Surface conditions include high temperatures, intense pressure, and a supercritical fluid atmosphere. Conditions for life on Venus are uncertain, with some indications but no conclusive evidence. Venus likely had liquid water in the past but lost it over time. Internally, Venus has a core, mantle, and crust, with volcanic activity shaping the surface. Unlike Earth, Venus lacks plate tectonics. It has no moons and rotates slowly in a retrograde motion, influenced by its dense atmosphere. Venus has the longest solar day in the solar system. Venus and Earth have the closest orbits among planets, periodically approaching each other. Venus has been a significant target for interplanetary exploration, revealing the extreme greenhouse effect and influencing our understanding of global warming. Crewed flights to Venus have been proposed as potential missions. In summary, Venus is a rocky planet with a dense atmosphere, extreme surface conditions, and historical importance in both culture and scientific exploration. Venus has a dense atmosphere primarily composed of carbon dioxide, 96.5%, and nitrogen, 3.5%, with traces of sulfur dioxide and water. Its atmospheric mass is 92 times that of Earth's, resulting in a surface pressure about 93 times greater than Earth's. The atmosphere generates a strong greenhouse effect, leading to surface temperatures of at least 735 Kelvin. Venus experiences a runaway greenhouse effect, making it a subject of interest for studying climate change on Earth. Billions of years ago, Venus may have had an atmosphere and surface conditions resembling early Earth, potentially including substantial amounts of liquid water. However, solar forcing and volcanic activity caused the evaporation of water and the transformation of the atmosphere. Despite the inhospitable surface, speculation exists about the possibility of life in the upper cloud layers, where conditions are more Earth-like. Venus's atmosphere is rich in primordial noble gases and differs significantly from Earth's atmosphere in terms of its composition. The dense clouds, mainly consisting of sulfuric acid, reflect about 70% of the sunlight back into space, preventing direct observation of the planet's surface. Venus experiences strong winds at the cloud tops, rotating about the planet every 4 to 5 Earth days. The surface of Venus maintains a constant temperature, with minimal variation due to its low axial tilt. Altitude is one of the few factors affecting temperature, with the highest point, Maxwell-Montes, being the coolest. Venus exhibits a cyclical variation in sunlight absorption, possibly linked to sunspot cycles. The existence of lightning in Venus's atmosphere has been debated, although evidence of lightning-like activity has been detected. Venus also features a double atmospheric polar vortex at the South Pole and an ozone layer high in its atmosphere. The ionosphere of Venus extends outward, resembling the ion tail of a comet. In recent observations, researchers discovered bow-shaped features in Venus's atmosphere, indicating the presence of large stationary gravity waves, possibly the largest in the solar system. In summary, Venus has a dense atmosphere dominated by carbon dioxide, extreme surface conditions, and unique atmospheric phenomena that continue to be studied and analyzed. The Venusian surface has been extensively studied through various missions and observations. It is predominantly covered by smooth, volcanic plains, accounting for about 80% of the surface. There are two highland regions called Ishtar Terra and Aphrodite Terra. Ishtar Terra is comparable in size to Australia and features Maxwell Montes, the highest mountain on Venus. Aphrodite Terra is larger and located near the equator. Venus exhibits evidence of extensive volcanic activity, with numerous volcanoes and volcanic features. It has more than 85,000 identified and mapped volcanoes, including large ones over 100 kilometers in diameter. The absence of small impact craters suggests a relatively young surface, estimated to be 300 to 600 million years old. Ongoing volcanic activity has been indicated by changes in sulfur dioxide concentrations and the detection of infrared hot spots. The planet experienced a global resurfacing event 300 to 600 million years ago, followed by a decline in volcanic activity. Venusian surface features have distinctive names, often inspired by historical and mythological women. The prime meridian reference point was revised from the radar bright spot at the center of the oval feature Eve to the central peak in the crater Ariadne on Sedna Planitia. The surface also exhibits unique volcanic formations like Pharra, Novae, Arachnoids, and Coronae. Overall, the study of Venusian geology has provided valuable insights into its volcanic history, surface composition, and ongoing geological processes. Venus is similar in size and density to Earth, suggesting a similar internal structure with a core, mantle, and crust. However, unlike Earth, Venus lacks evidence of plate tectonics and an internally generated magnetic field. The absence of plate tectonics may be due to the strength of Venus's crust, which inhibits subduction. The lack of a magnetic field is thought to result from a lack of convection in Venus's core. The core state is uncertain, with possibilities ranging from a completely solid core to a core without a solid inner part. Venus's weak magnetosphere allows the solar wind to interact directly with its atmosphere, leading to the loss of low-mass ions and potentially causing the erosion of its water over time. Venus's orbit is nearly circular, and it has a retrograde rotation, meaning it rotates clockwise when viewed from above the North Pole. The length of a day on Venus is longer than its year, and its rotation period has been influenced by tidal effects and planetary perturbations. Venus has no natural satellites but has some Trojan asteroids and a dust ring cloud in its orbital space. Venus and Earth have a near-orbital resonance, with Venus orbiting the Sun 8 times for every 13 orbits of Earth. This results in Venus and Earth approaching each other and reaching inferior conjunction every 584 days on average. The path that Venus makes in relation to Earth forms a pentagram over 5 synodic periods, creating a visual pattern known as the petals of Venus. During inferior conjunction, when Venus is between Earth and the Sun, it comes closest to Earth at an average distance of 41 million kilometers, 25 million miles, making it the planet that approaches Earth the closest. However, Mercury is more frequently the closest planet to Earth. Venus exerts the third strongest tidal force on Earth, after the Moon and the Sun, although its tidal force is significantly weaker. Venus appears as a bright white point of light in the sky and has the lowest gravitational potential difference to Earth among all the planets. It is often visible in broad daylight and can be seen when the Sun is low on the horizon or setting. Venus transitions between being the evening star visible after sunset and the morning star visible before sunrise. It displays phases similar to those of the Moon when viewed through a telescope. Observations of Venus during daylight hours have been recorded throughout history, and there have been historical sightings of Venus's crescent shape. Transits of Venus, when Venus passes in front of the Sun during inferior conjunction, have been historically significant for determining the size of the solar system. Only 7 Venus transits have been observed so far, and the next transit will occur in December 2117 and December 2125. One intriguing phenomenon associated with Venus is the ashen light, which is a faint illumination observed on its dark side during the crescent phase. The existence of ashen light has never been reliably confirmed, and it remains a mystery in Venus observations. Throughout history, Venus has been recognized as one of the brightest objects in Earth's sky, visible without the need for any aid. Different cultures have identified Venus as the morning and evening star due to its apparent discontinuous movements. Some cultures initially believed Venus to be 2 separate stars, but ancient Sumerians and later civilizations recognized it as a single celestial object. In Chinese culture, the morning Venus was referred to as the Great White or the Opener of Brightness, while the evening Venus was known as the Excellent West One. The ancient Greeks also initially believed Venus to be 2 separate stars, but it was Pythagoras and later Parmenides who realized they were a single object. The Romans continued to use separate names for the morning, Lucifer, and evening, Vesper, aspects of Venus. In the 2nd century, Ptolemy theorized that both Mercury and Venus are located between the Sun and the Earth. Avicenna, a Persian astronomer, claimed to have observed the transit of Venus, which was seen as confirmation of Ptolemy's theory. However, it was Galileo Galilei's observations in the 17th century with a telescope that revealed Venus's phases, indicating that it orbited the Sun and contradicting the geocentric model. In 1639, Jeremiah Horrocks accurately predicted and observed the transit of Venus, providing valuable data. The atmosphere of Venus was discovered in 1761 by Mikhail Lomonosov, and Johann Schroeder observed its atmosphere and determined its dense nature. Early 20th century advancements in spectroscopic and ultraviolet observations provided further insights into Venus's rotation and atmospheric composition. Spectroscopic observations in the 1900s revealed that Venus had a longer rotation period than previously thought. Ultraviolet observations showed details in the atmosphere that were not visible in other wavelengths. The lack of oblateness in Venus's disk initially led to the belief that it was tidally locked, but the detection of heat from the planet's night side indicated a retrograde rotation. In summary, historical observations and scientific advancements have gradually revealed more about Venus's characteristics, rotation, and atmosphere, shedding light on this fascinating planet. Since the first interplanetary spaceflight in 1961, numerous missions have been conducted to study Venus. The Mariner 2 mission in 1962 provided valuable data on Venus's atmosphere, while radar observations in the 1960s revealed the planet's rotation period. The Venera missions in the 1960s and 1970s successfully landed on Venus and transmitted data back to Earth, uncovering details about the planet's temperature, atmosphere, and surface. In 1970, Venera 7 achieved the first soft landing on another planet and transmitted data from the surface. The Mariner 10 mission in 1974 used a gravity assist from Venus to redirect its path toward Mercury and captured ultraviolet photographs of Venus's clouds. Radar observations during the 1970s provided insights into the Venusian surface, including the discovery of the Maxwell-Montes Mountains. The Pioneer Venus project, consisting of the Pioneer Venus Multiprobe and Pioneer Venus Orbiter missions, operated from 1978 to 1992 and gathered additional data about Venus. The Soviet Venera program, including Venera 9, 10, 13, and 14, obtained the first images of the Venusian surface, with Venera 13 and 14 capturing color images in 1982. The Vega program in 1985 deployed entry probes and the first extraterrestrial aerobots, achieving atmospheric flight with inflatable balloons. The Magellan mission from 1990 to 1994 mapped Venus's surface, and subsequent flybys by missions like Galileo, Cassini-Huygens, and Messenger provided further insights. In 2006, the European Space Agency's Venus Express mission entered orbit around Venus, offering unprecedented observations of the planet's atmosphere. Currently, Japan's Akatsuki is the only active mission at Venus, having achieved orbital insertion in 2015. Other missions like NASA's Parker Solar Probe and ESA's Solar Orbiter and Bepi-Colombo have performed flybys of Venus as part of their journeys. Several probes are currently under development, and multiple proposed missions are in early conceptual stages, highlighting continued interest in studying Venus. After the early 1960s, speculation about the possibility of life on Venus's surface decreased significantly due to the extreme conditions found there, such as high temperatures and atmospheric pressure that make water-based life unlikely. However, scientists have speculated about the potential existence of extremophile microorganisms in the cooler, acidic upper layers of Venus's atmosphere. In 2019, astronomers observed long-term changes in the atmosphere of Venus that could be caused by unknown absorbers, potentially including microorganisms. Similar conclusions have been reached by other studies. In 2020, the detection of phosphine, a gas not known to be produced by known chemical processes, raised the possibility of its origin being living organisms. However, subsequent analysis raised concerns about the detection method, and reanalysis of the data did not show a statistically significant detection of phosphine. The Committee on Space Research has categorized Venus under Planetary Protection Category 2, indicating a remote chance of spacecraft contamination compromising investigations. In January 2025, a project led by the Massachusetts Institute of Technology and Rocket Lab plans to launch a private interplanetary spacecraft to Venus, aiming to explore the atmosphere and search for organics. Overall, while the harsh surface conditions of Venus make the existence of life implausible, the exploration of Venus's atmosphere and further investigations continue to generate scientific interest and ongoing research. Venus has been a significant destination for robotic missions, marking the first successful landings on another planet and the only nation to send lander probes to its surface being the Soviet Union. Currently, the Akatsuki spacecraft is in orbit around Venus, and other probes utilize Venus for gravity-assist maneuvers, gathering data during their journeys. In terms of crewed missions, studies have proposed using Venus gravity-assist flybys as part of routes to Mars, showing potential advantages such as shorter and safer mission durations, better return or abort flight windows, and comparable radiation exposure to direct Mars flights. The Soviet Union and the United States previously considered crewed flyby missions to Venus, although they were never carried out. Despite the inhospitable surface conditions of Venus, the atmospheric conditions at higher altitudes, around 50 kilometers above the surface, are comparable to those on Earth in terms of pressure, temperature, and radiation levels. In light of this, the use of aerostats, floating structures, for crewed exploration and even the establishment of permanent floating cities in Venus's atmosphere have been proposed by experts like Sergei Zytomyrsky and Jeffrey A. Landis. However, significant challenges, such as the corrosive sulfuric acid in the Venusian atmosphere, would need to be addressed for human presence in Venus's atmosphere. NASA's high-altitude Venus operational concept is one mission concept that has proposed a crewed aerostat design for exploration and study of Venus's atmosphere. Venus holds significant cultural and mythological importance throughout history and across different cultures. The English name for Venus originated from the ancient Roman goddess of love, who was based on the Greek goddess Aphrodite, and both goddesses were associated with the planet. In Sumerian and Akkadian religions, the goddess Inanna, Ishtar, was also associated with Venus. Various hymns and myths highlight the correlation between Inanna's movements and the movements of the planet Venus in the sky. For example, Inanna's descent to the underworld mirrors the descent and rise of Venus in the sky. The ancient Egyptians and Greeks recognized the morning and evening star as one celestial object, associating it with different deities. Classical poets like Homer, Ovid, and Virgil praised the star and its light, while modern poets also wrote odes to Venus. In Indian Vedic astrology, Venus is known as Shukra Graha and is associated with wealth, pleasure, and reproduction. In Indonesian and Malaysian Malay, Venus is referred to as Kejora. In Chinese, Japanese, Korean, and Vietnamese cultures, Venus is called the metal star due to its association with the metal element. The Maya considered Venus as the second most important celestial body after the Sun and Moon. They referred to it as Chekak or the Great Star and incorporated its cycles into their calendar. In the realm of science fiction, the impenetrable cloud cover of Venus allowed authors to speculate on habitable conditions on its surface before the reality was known. As scientific knowledge progressed, science fiction narratives shifted to explore the concept of terraforming Venus. The Venus symbol, a circle with a small cross beneath, is associated with the planet and represents femininity. It is also used as the gender symbol for females. In Western alchemy, the Venus symbol represents the element copper. Other symbols associated with Venus include the crescent and the star, such as the Star of Ishtar. As our cosmic journey comes to an end, we hope this exploration of Venus has ignited your curiosity and deepened your appreciation for the wonders of our universe. Venus, with its captivating beauty and intriguing mysteries, reminds us of the boundless possibilities that lie beyond our own planet. Remember to keep looking up, for the night sky holds endless wonders waiting to be explored. Whether it's the planets, stars, or distant galaxies, each celestial body has a story to tell and secrets to unveil. We encourage you to continue your quest for knowledge, to embrace the wonders of science, and to never stop exploring. Together, let's unravel the mysteries of the cosmos and marvel at the incredible vastness of our universe. Thank you for joining us on this cosmic journey. Don't forget to like, subscribe, and hit that notification bell to stay updated on our future adventures. Until our paths cross again, remember, the sky is not the limit, it is only the beginning. This is Cybot GPT signing off.